All right, we're going to look at how we get the k-values for the function in the assignment. And what I'm going to do is open up the file that you guys have downloaded from Angel. What you see here is the template, and we need to. I didn't explain in the first recording how to get these mysterious k-values, and if you actually have to go and implement this and provide error bars on your analysis, you actually have to get these k-values, and it's actually really easy with an Excel here. So what I'm going to do is I'm just going to open up a blank sheet. I'm going to note the function e to the x times the square root of 1 plus e to the x. I'll have to remember that here in a second. And what I'm going to do is I'm just going to build a little function table here that allows me to look at that. So I'm going to go over here and just create what I call constants. I'm going to create a start, an end, and an increment. And just set those up. And the bounds of integration was from -2 to 1. And let's just nominally start with an increment. We could go 1/10 or 1/100th. I'm going to specify this at 1/100th. These are all adjustable. And then what I want to do is I want to start with my beginning value. So I'm going to select the cell I just started with. This is going to be a formality for what I'm going to show you, but out of habit, if you want to build a function table to look at and examine, this is a handy way to do this. Let's just set that to an absolute cell reference by pressing F4. Now I'm going to increment this. So I'm going to seed this off of my start value, and I'm going to add my increment to that. And with the increment, you definitely have to make that an absolute. The cell before I didn't, but this one you do. Set that up. And I'm just going to let that, I can drag this down a little bit. I can build an interesting thing here. I can say number of cells that will tell me, how many cells I need to drag this out to. I'm just going to do the b minus a divided by the increment. This is just like we did for the approximate integration. It tells me I have to drag this out to 300 cells. So I'll do that here in a second. I'll show you how to do all of this, drag it all out down the whole way down to 300 in a very convenient way. So the very first column to the right of this, these are going to be my x values. So I can sort of put in a little. What I'm going to do is I'm going to build a table. And then what we're going to look at the derivative, and we're going to look at the second derivative and the third derivative and the fourth derivative. Just like that, and square those up. Now my function was e raised to the x. Now these are of course my x values, so I want to raise that value. And I want to multiply the square root of this cell. I'm sorry, the square root of 1 plus e to that cell. And I have my function articulated like this for the f of x. And we can sort of, that's sort of just decoration at this point. Now, for f of x, how do I get a derivative in Excel? We do a method called finite differencing. And just like when we do rates of change, we do approximate derivatives, that's essentially what we're going to do here. So I'm going to say, basically, change in y over change in x is all I'm saying. So I can say this value minus this value divided by my increment, which is the same as my delta x, right? This just is a much more convenient way to say that. And I'm going to absolute cell reference that, so when I fill my formulas in, that reads correctly. So this is a way to do finite differencing. It's going to give me a very good approximation to the derivative at a point between these two values, so 1.995, which is immaterial to what we're trying to do. Notice how I had to start one down because I'm using this value. When I do the second derivative, it's going to be the same thing, except I'm going to have to start one further down. Check this out. I didn't even have to enter a cell formula. I was just able to drag it sideways. And I got the right C4 minus C3 divided by my absolute cell reference to this. Bring that down, and then for the third derivative I have to go one further down and drag that down, and I can get all four derivatives. It's not O. And drag things down like that. Now it's telling me I need 300 cells. So what I'm going to do is I'm just going to clean this up a little bit and say that, and I'm going to go to cell A300. I'm going to go 301 cells down because I put in a header row, which offsets things. So this is going to take me to cell 301, A301, the whole way down. And I'm going to go over to, this is my x column, this is my f of x, first, second, third, fourth derivative, and I'm going to highlight those rows. Shift, Control, Home takes me back up, and go down to the last row. Now I'm going to go over to Fill, and I can't see it on my abbreviated fluid user interface. It's right there. It's a little, if you have a full screen, you will see this. It will say Fill, and it'll have that icon. And I'm going to fill down. And what it did was it filled the whole way. If I do Control End, I can go to the very bottom of my data. You can see it filled in 300 rows. Okay, I'm going to select this row, 300, and I'm going to do Shift Control Home, Shift, bring this down, and what I can do is I can hide these columns. What that allows me to do is see the end and the cells that lead up to that interruption. So I don't need to display all of that data. I'm going to add one more title in here. I'm going to say max value of f, the fourth derivative, and I'm going to say the max value of hover over that, double click, square these up so that they're nice and pretty, and then I'm going to say this max value of this column. Close those parentheses up. That's going to find the maximum value in my f to the fourth derivative, or my fourth derivative. That makes sense. If this is an exponential function that's increasing continuously, that the last value would be my maximum. Using the max function, make sure that there is no other maximum values between here and here. Now I'm going to do the same thing for f of x. And I'm just going to say, so I'm going to go to my second derivative column. And the max value for my second derivative is 9.948. So I have these values. So what I could technically do is I could, when you populate your template, if you want, you can just cut and paste. You can manually enter the number. But just so you know, you can go between sheets and you can assign values. So I go over to this sheet, I press Enter, and it dumps this value in. It's linked, you can see up here in the formula bar, it's linked to sheet 1. And I can do the same thing here. I go next door, put that value in, and I get my max K values. Dynamically referencing things like this in a real spreadsheet when you're doing something is often handy, because if I made a mistake here, these values would be updated, which would then update these values automatically. All I have to do is go back and correct my mistake. If I already entered this expression, something, or however that mistake will be manifested. That's how you get the maximum value of k. So you can apply this same method and find your k values for the 1 over x times natural log of x, the next function you'll be doing for the last half of this assignment. Hope that was helpful. Good luck.